So I'll get us going. So my name is Shay Sinnott. I work with Foresight Canada, Director of Programs on our acceleration team. And it's a pleasure to welcome you to Climate Connections. Agriculture and water is our focus for today. I'd love to see a sign of life for those that have your video on. If you can give me a wave, a thumbs up. For folks that are off video, give me an emoji or an emoticon response if you know how to do that. And I'm curious, for those that can wave or can do an emoji, for whom is this their first Climate Connections event? Just looking at our screens here. Yeah, cool, lots of new people. Great, welcome, welcome. So moving along, Thomas, if you can, in the slides. We kind of started acknowledging where we were, but I want to acknowledge with gratitude and respect where I am. So Foresight Canada works across the country, but I am based here in Vancouver on the lands of the Musqueam, Squamish, and Tsleil-Waututh peoples on unceded Coast Salish territories. So as Nisha did, if you know where you are on Indigenous lands in the country, that'd be great to hear too. And by way of tying this acknowledgement into our event for today, I guess just want to express gratitude and respect to people that feed us. Tons of gratitude for the food from the land and all of our farmers and people that work in our agricultural space. And then also something I've learned from Indigenous peoples and cultures over the years is how sacred water is, and that water is life, as something you'll often hear from Indigenous peoples. So I wanted to tie us into our theme for today. So thanks for that. So moving right along, our purpose. So for those that are new, Climate Connections is very intentional in how we structure the event. It was born from Foresight Canada and Entrepreneurship UBC, as you'll hear, coming together to explore how might we create an event series that brings together solution seekers and solution solvers. So what about if we put on an event where we have people with real world industry challenges and we get them to present their challenges to a group of, as you'll see, researchers, academics, innovators, and entrepreneurs to kind of bust up the way that we do our events. And so the purpose here is to explore these challenges that you're going to hear from our wonderful speakers today, Dana, Bill, and Kyle, and then also hopefully create space for some connections between all of you. And so that's our purpose for today. I also want to acknowledge and thank our partners. So we have tons of partners at Foresight Canada, but I really want to call out IRAP for their ongoing support, especially for our water work. And so thanks so much to IRAP. Moving right along. This is our agenda for today. So I'll try to move us along quickly and get into the good stuff with our panel of industry experts. And we'll hear from each of them. We'll explore the problems or the challenges that they're presenting. And then we'll break out into breakout rooms. So we'll have 2 breakout rooms where you can pick the room that you're most interested in based on speaking to, in this case, Bill or Dana, Dana or Kyle. Bill will have to hop up a little bit early and then explore, as we said, connections on these challenges that they're going to present. So that's our agenda for today. And I think I might pause here. Yeah, great. And let's just do a little roundtable of introductions. So we'll go in order: Kyle, Dana, Bill. If you could come off mute and introduce yourself, who you are, where you are, and what you're hoping to get out of today. That'd be great to hear from you. So let's start off with Kyle.
Sure. Thanks, Shay. And I apologize for the moody lighting. The sun is just going down here in Winnipeg. So, but yeah, so my name is Kyle Hiebert. I'm a senior analyst with Enterprise Machine Intelligence and Learning Initiative. It is a nonprofit organization based in Winnipeg, focused on digitalization and intelligent solutions for the whole of the food supply chain, focused primarily on Manitoba, but across the prairies. It's historically been focused on digital agriculture, but this past year we got involved in helping to create a roadmap for Manitoba's provincial water management strategy, which was just released last week. So we handled a lot of the stakeholder engagement around that, led some strategic water projects, and then also did some background research and analysis into other jurisdictions.
Awesome. And what are you hoping to get out of today?
Today, I'm hoping to get some insights around innovation in irrigation. So obviously this connects pretty directly with the nexus that Emily works in within intelligent solutions, agriculture, and water. both to mitigate risk, but then also take advantage of a lot of great opportunities around agriculture in Manitoba. A lot of times irrigation is specifically geared towards mitigating risk, but we also see a lot of opportunities. So we're hoping to tap into some bright minds attending and get some ideas and hopefully open some avenues for collaboration in the future.
Awesome. Well said. Thanks, Kyle. Next up, Dina, can you introduce yourself? What you're hoping to
Yes,
today?
I'd love to. I'd love to. Thanks so much for having me here today. I did not put in the chat what lands I'm on for a really kind of an interesting reason. I actually am in Shelburne, just north of Toronto by about an hour and, I don't know, an hour and a quarter. And I live very close to Huron-Ontario Street, where it's a portmanteau for Lake Huron and Lake Ontario. And it got its name because this was the natural conduit that First Nations people have been using for many, many centuries to move between the two lakes. So I live in an area that, depending on the season, would have been inhabited and foraged and hunted by many, many different types of First Nations people. So, and quite apropos for today is that, this was a trade route to bring goods from one lake to another. And I think that's kind of interesting when we think about the role water plays in food, that that I'm in this situation. But I'm representing the Canadian Food Innovation Network today, my employer, and we exist to champion innovation in the food industry. And that means that we're really interested in a lot of things, but with reference for today, we have three innovation priorities. One is smart product and process design. The other is food ecosystem sustainability, and then agile and safe food supply chains. And there are projects and members in the CFIN network who are interested in water that and have touch points to all three of these priorities. So I'm excited to be here today. A core value of CFIN is collaboration. We're all about bringing people together and finding solution owners and problem owners who can work together regardless of where they live. So I'm really looking forward to seeing how this community has developed this cool concept and understanding whether or not it's something that we could learn from at CFIN. So thanks again.
Awesome. Thanks, Dana. And thanks for that acknowledgement of where you are too. And last but not least, Bill.
Hello, everybody. My name is Bill Whitelaw. I'm the Managing Director of Strategy and Sustainability for geoLOGIC Systems. And geoLOGIC is a global energy intelligence firm. We operate across North America and Europe and India. But I have a long history of working in the agricultural sector on a variety of initiatives. And the climate has always been a focus of the products and services that we had. And I chaired the Smart Innovation Supercluster process, which many of you will recall from a few years ago. We were one of two superclusters in the ag space shortlisted for the final process. And we lost out to a wonderful organization called Protein Industries Canada. Both organizations looked at water extensively. And but what I hope to get out of today is a conversation around how we create new spaces for entrepreneurs and innovators and academics to research problems in a different way. And so I'll be coming at this from the ag energy interface with a particular spin on the Alberta context. And what I hope to come out of it is sort of an conversation around how we can think differently about some of these artificial boundaries that we put up in terms of calling it the energy sector or the oil and gas sector and ag sector, and realize that it's all one set of integrated and interconnected dynamics. So thank you, Shay.
Nice. Thanks, Bill. Okay, moving right along. I'm going to pitch to our partners at Entrepreneurship at UBC in just a second. So we're missing Tom Urban on that slide. Thanks, Tom, for joining us. But first, I'll just tell you a little bit about Foresight Canada if you don't know our work. So we have a big, bold mission at Foresight. We want to enable Canada to become the first G7 country to reach net zero. We're lagging behind other countries. I just saw some worrying report backs from where we measure in not just the G7, but internationally, and we have a lot of work to do, and we are motivated and inspired to do it. We do that in many ways, but what we do especially is we bring together partners across what we call our Helix 5 in order to launch, commercialize, and scale the clean tech we need to address today's most urgent climate challenges, but also broadly speaking, our environmental challenges. And this includes, if we go along to the next slide, a range of acceleration programs. That's where I work, where Thomas works on the acceleration team. We also run innovation challenges, we do research, we attract capital and engage investors, especially making those connections between our ventures and investors, focus on export development, and then of course, ecosystem building with events like our Climate Connection series. So that's a little bit about us. And next up, Tom Urban, thanks so much for joining us. I don't actually know your title. If you could introduce yourself, if you could tell us more about entrepreneurship at UBC.
I will, thank you. So Tom Urban, I am an entrepreneur in residence at UBC, but mostly what I do is I've been working in agriculture my whole life on the genetic side with seed. But for the last 10 years, I've been an early stage investor and advisor for production ag companies. So a lot of companies around water, companies around robotics, companies around alternative protein, that kind of stuff. But at entrepreneurship at UBC, obviously we're housed within a university. And at the highest level, we're really interested in taking all of the horsepower and the science that is created within that university structure and getting it to find its way to commercialization, right? So providing them with a whole bunch of things that they need to make that journey. If we go to the second slide, and the way that happens in the university context, there's multiple mandates, right? There is an educational mandate. And so there are a series of programs that are fairly loose, but really trying to support professors, graduate students, anybody who's interested in learning about entrepreneurship. And that's that kind of big circle you see there, which is Entrepreneurial Explorer. It's really a sort of a loose education around what entrepreneurship is. When people get a little more focused on actually building a venture, we have a process where we can really give them the building blocks, and it's everything from what's a value proposition to what's a cap table to really the pieces of how one might commercialize a set of ideas or technologies. And then really the third part is where people are committed to really building a business. They have a small team, they have some IP, they have an idea, and we're really trying to move them to the point where they're getting to first revenue. They're ready to leave the building and get out and produce companies. And we've been successful. I won't go through all the numbers, but they're pretty impressive in terms of how many companies have come through, what capital they've raised, economic impact, et cetera. And the last slide, if we could, is laid over that whole idea of sort of inspire, educate, and train are some themes. And one of the themes is the Climate Venture Studio. One is a human health theme, and the other is a social venture theme. The concept is fairly simple. That within these themes, there are some unique aspects of those areas where it could be in terms of how one raises capital, the messaging, regulatory. There are some things that are common across these themes, and so we've chosen to provide some additional structure around. And Shannon was hoping to be here today, but obviously she leads the Climate Venture Studio. Which is, very much focused on the kinds of concepts and ideas that we're talking about today. So ultimately, we're trying to get science out of the lab, commercialized, applied in the world, and making a difference.
Thanks, Tom. I've heard that intro several times before, but I always love hearing about your work. I really appreciate the structure of what you do. Awesome. Okay. That's all of our introductions to our wonderful people here today. And now we're going to get into our industry experts panel. So in order, we're going to hear from Kyle, Dana, Bill. Each speaker will have about 3 minutes to present their challenge. of a couple slides each. And then what we'll do is take a couple burning questions from the audience if you have them, any clarifying questions. By all means, you can always share questions in the chat, though at one point we will ask you if you want to raise your hand and speak up, then that's fine too. So each person will have about 3 minutes. We'll do back to back. And then we're going to open it up to questions for the full group before we move into breakouts. Yeah, thanks, Nisha. We'll be keeping our eyes peeled on the chat. So first up, Kyle, when you're ready, I'd love to hear about the challenge you're presenting.
Great, thank you. Thomas, I think if you can put my slide up just with the our reverse pitch there. So essentially both industry and government in Manitoba are looking to support the expansion of irrigation systems that can retain surface water in times of excess, distribute it and use it more efficiently in times of need, and then also store it in between. So what we're looking for really is to push solutions that revolve around cutting-edge innovations to do this, that are replicable and can enhance irrigation capacity at the on-farm level at a price point that's accessible to a producer running an average 1,200-acre farm. So as mentioned, Emily last year in the spring of 2021 entered an agreement with the government of Manitoba to come up with the roadmap for the new provincial water management strategy. Our province hasn't had one since 2003, and obviously the world's a lot of a different place now. So we did that over the past year. We submitted 60 short and long-term recommendations to the province. They released their new water management strategy framework this past week, adopting the majority of our recommendations with an action plan due this spring. So one of the key factors that drove Emily's involvement specifically into the water management space is to push for an increase in irrigation capacity within the province. This is envisioned as part of a closed loop multifunctional storage system of retention, storage, and distribution nodes. Manitoba has been sort of affectionately referred to as the bathtub of North America. It's the convergence point of 3 other provinces and 4 states. And just for perspective, 70% of the water renewal in the province annually comes from outside of the province. So we're really reliant on other jurisdictions for that water coming through, which creates sort of some transboundary issues. And it has really focused attention in Manitoba to really increase that efficiency because we're so dependent on inflows from other areas. But going forward, drought will become just as much of an issue as flooding. So historically, Manitoba has been viewed water as a liability because of the increased amount of flooding, but drought going forward will be just as much an issue. So for example, Manitoba experienced its worst ever drought conditions in the summer of 2020. And less than a year later, we reached our highest ever levels of precipitation this year by October already. So that just shows you that the swings that are expected. And at the same time, as this has been going on, southern Manitoba itself has become a hub for value-added agri-food processing. Several companies in the potato processing and plant protein space have opened up facilities worth hundreds of millions of dollars on sort of the expectation of access to water based on Manitoba's reputation of having an abundance of water, and also the fact that 97% of our electricity in the province is created through hydropower. So that provides the green incentive for companies that want to come here, both for water and renewable power to generate and use in their operations. But because of some water issues and sort of capacity issues within growers, a lot of these companies are having to either taper their output now based on what they thought they would with their facilities, or some are even importing raw product from outside the province to meet their production quotas. So what we're really looking for is innovations in irrigation. This matters for food security, but also to de-risk the huge investments that growers make every year in planting, fertilizing their crops. Input prices are on the rise, just as food prices. So irrigation is one tool to ensure that crops can grow in the most productive way possible. There's also specifically a concern that with existing models of above ground multifunctional storage, a lot of them tend to have a significant amount of evaporation in the stored water supply that takes place. So as the season goes on, and especially as it gets hotter and hotter in the years going forward, current models of multifunctional storage really reduce in their availability of the water that can be stored throughout the season due to the evaporation. So as Manitoba just embarks on its new water management strategy, both growers and processors and the government are looking for more reliable and adequate supplies of water to take advantage of market opportunities while also protecting production from disruption by extreme weather. But right now, Manitoba is behind the curve compared to jurisdictions like Saskatchewan and specifically Alberta that have a lot more of that legacy irrigation infrastructure in place to build upon. For comparison's sake, Manitoba has less than 1% of its cropland irrigated right now, which is about 48,000 hectares compared to about 600,000 in Alberta, and Saskatchewan has about 200,000, I believe. So Manitoba's really looking to find ways to, while both pursuing larger scale expansion of irrigation, really find a way to bring that to the direct on-farm level for producers, both because irrigation itself will help with the production, but also because a lot of dry land operations are going to be looking to just irrigate their crops out of necessity going forward. So it's both a tactic we're pursuing to try to increase the sort of the value added crops that go directly into our agri-food processing industry, while also providing tools to the average producer to just protect their crops, dry land, traditional crops, soy, canola, wheat, from just extreme temperatures going forward. So we're really excited to participate today and hoping to come across some new ideas and really develop some relationships with others that are interested in the space to see if we could come up with collaborative solutions going forward. That is my pitch. I hope I made it on time.
You did, yeah. Thanks, Kyle. We have a question in the chat. I'm just going to read it out. Is the water distributed through a canal system or by pumping from water source is the question I see.
So right now, producers that irrigate crops are specifically using some kind of sprinkler irrigation system with pipeline delivery to that sprinkler system, whether that is from existing reservoirs. Right now, like I said, there's not a lot of legacy irrigation in Manitoba. So the irrigation that has been adopted is sort of advanced, is sort of the leading edge of what's available. Irrigation method of choice right now for the individual producer is based on the number of sprinkler systems mapped out in multiple watersheds. And producers appear very much aware of the water savings and operational cost savings gained with sprinklers and pipeline conveyance versus other irrigation methods such as gravity irrigation. So it does seem to be that setup. There just is not a lot of it right now.
And clarifying question from me, the reason that those systems are not in place is indeed because, maybe this is a dumb question, but because things have changed. And that's why we're seeing these wild swings between, formerly the issue was too much water.
Yeah, so that's the reason that Manitoba has perhaps lagged on installing irrigation capacity, because it has historically had an abundance of water. So everyone was concerned about tile drainage and getting water off the land in the past. And right now, with the extreme weather, now we're realizing, well, that water that is being moved off the land is actually a lost asset if you can close that loop between flood mitigation, but also crop irrigation.
Okay. And one more question from me. Are you aware of others that are looking into a similar problem? I'm imagining another location or geography with that similar kind of swing issue of the twofold challenge.
Yeah, so others that are looking at it right now specifically are, Alberta is way ahead of this. They have just closed a nearly $1 billion deal with the Canadian Infrastructure Bank to do this exact sort of thing. So to expand irrigation capacity within southern Alberta that also acts as flood mitigation and can feed into their agri-food processing industry. So just for some comparison's sake, Alberta's history with their irrigation, it's been decades long, but right now 5% of their land within southern Alberta is responsible for 20% of their agricultural output. So that just shows that the amount of increased production that can happen while saving water is possible. And Alberta's ahead of that, but they're now operating at a much larger scale. We are pursuing opportunities with the Canadian Infrastructure Bank, but those obviously take time to unfold, to get funding in place, to get shovels in the ground. So we're trying in the meantime to find out if there's other means that the sort of smaller scale producers can either use technology on their farm, or smaller groups like water cooperatives in the areas or groups of municipalities can sort of bring about smaller scale technologies to achieve that in the short term while the larger infrastructure is being built out.
Okay, got it. Thanks for that. There's another question from Tom, but I'm going to suggest that we hold that question and maybe come back to it when we open it up overall so that we can move ahead to Dana. when you're ready. And we will copy paste all this contact info into the chat, no worries. Oh, and you're muted, Dana.
Only about the 20th time that that's happened to you today. Anyhow, thanks very much. So I mentioned that CFIN is interested in championing innovation in the food industry. So we work post-farm gate, but agriculture needs to know what the food industry cares about, the same way that both agriculture and the food industry needs to know what retailers and consumers care about. So I have prepared a challenge that is somewhat hypothetical, but I wanted to show the group that there are companies working on and championing innovation in how to work with agricultural products in a way that optimizes them. So, obviously having clean, fresh water and is beneficial in many ways. But when you're thinking about shipping foods from one place to another, when you're thinking about the freshness and longevity of foods, water activity is something that food scientists are always measuring within a food product to understand how to control antimicrobial growth and freshness, et cetera, et cetera. So my challenge is, how can we either recapture water or how can we eliminate water at certain points in a product's journey from farm to fork to help us to get a more stable supply of nutrient-dense foods to consumers more easily, more effectively, with less greenhouse gas emissions, etc. So these are two projects that CFIN has funded through our Innovation Booster program. And there are many more on our we have a platform called Yodel, which is kind of similar to the Slack group that Foresight Canada has, except just a little bit bigger and more robust, where our 2,100 or so members talk about all kinds of things. And so we scan what they're talking about and make word clouds and things of that nature. And we do know that getting the most nutrient-dense food to people, not just in Canada, but around the world, is something that a lot of entrepreneurs and a lot of businesses care about for economic as well as other reasons. So I'll quickly go through these two examples for you. Trendy is a food tech company from Vancouver, Canada. I took that picture that you see there 2 weeks ago when I went out to visit them. They have a really interesting, inside that trailer is a little processing facility. And they go on farm with these machines, these trailers equipped with machines. And any produce that is off spec, meaning it can't go to the customer who contracted the growth of these products, goes through the biotrim system where it's cleaned, it's processed, the water is extracted from it, but it's done in such a way that the resulting powder that's left over, whether it's fruit or vegetable, has lots and lots of nutrients, vivid, beautiful color, and it can be used in many ways as an ingredient, certainly. But Trendy's also developed both a smoothie machine and they're working on now a soup machine, so that there can be access in food deserts and in places like nursing homes and schools and cafeterias, access to made on demand fresh soups and smoothies that have all of the taste and many of the nutrients that you would get out of making the same products using really fresh ingredients. Yet they have almost maybe not unlimited, but a very extended shelf life, and can be shipped very inexpensively because they're lightweight and they don't need to be kept in refrigerators or freezers. Forward water technologies, and I will tell you that picture there is supposed to represent how many oranges it takes to make a glass of orange juice. And I will be 100% honest and tell you that it's really actually for 1 cup of orange juice, it takes about 2 oranges, normal medium-sized oranges, to make a cup. So that's quite an exaggeration. But Forward Water Technologies is an interesting company, also working against a similar kind of a challenge, whether intentionally or not, to use water, to reclaim water within food processing systems so that it can be, wastewater is rehabilitated and can be used to make make potable water or used in food processing. But their latest idea, if you've ever made a concentrate, if you've ever been to a maple syrup shack, for instance, you know that you boil to get things down to being in a concentrated format. Well, Forward Water Technologies realized that 1, there's a lot of greenhouse gas emissions that happen that way, but 2, that water just goes into the air, which isn't necessarily bad for our sinuses and for other things, but certainly that water has value and can be used in other ways, particularly in places that are increasingly threatened by climate change and are having drought. So they've developed this new system that combines some technology that is a little bit past my technological understanding, but in a nutshell combines geothermal and reverse osmosis to create very, very dense concentrates from foodstuffs that require much fewer greenhouse gas emissions and can recapture that water to be used for other things, and are much more nutrient dense than the types of examples that would be the other types of concentrates that have been used for a long time to make frozen orange juice, et cetera. So my challenge is how can we be inspired by innovators like Trendy and Forward Water Technologies to think about the way we prepare food, not just to be moved, but also how we make sure that it's as nutrient dense and as bioavailable as possible. So that's what I have to say about that. So.
Thanks, Tina. Yeah, I appreciate that you framed up a challenge that is asking a couple different questions about like reutilizing water, and then also coming up with more nutrient-rich food, and then proposing a couple solutions. I'm curious, like, how do they fall short, or what's off about those solutions? Or
there's nothing off about these solutions, but yeah. I think that this is, a place, an area where there's lots more opportunity. So these are 2 approaches, and the same way that all roads can lead to Rome. And when you look at a map of Italy, I think there are many other paths that, and I suppose if I wanted to be a little bit more reductive, I would say, how can we rethink the way we think about our traditional processing of these fresh ingredients, so that water is not necessarily a given, and that there is another way to use the water, but also optimize the way the food is prepared. And these are 2 examples of how in the biotrim, the water is removed and it can go right back into irrigation. And in Forward Water Technologies, the water is removed and it can go into other uses in a food plant, like sanitation, or being used to make other things that might be made in that same facility that requires the addition of water.
Nice. Yeah, I appreciate the crispness of rethink the way we process food. so that water isn't necessarily a given. I like that. Also, I was drinking a glass of orange juice as we were talking, which feels very on brand.
Wow.
Okay, thanks, Dana. So if there are no burning questions for Dana, then I think I will move us along to Bill. And again, we'll copy all this contact info into the chat. Bill, when you're ready, please feel free to chime in.
Thank you. And Thomas, if you could put up my slides. And I like this because it has a nice alliterative feel to it in terms of fracking and feedlots, but it's a uniquely Alberta question in many ways. And one of the things I should have said in my introduction is I sit on a board of an organization called Agriculture for Life. And we do a whole range of things, but sustainability in the agri-food value chain is our big focus. And part of that programming is that we deliver ag in the classroom curriculum to schools across Canada. And what we recently rebuilt our curriculum on the UN's SDG structured framework. And of course, we have a real strong water focus. And so where I wanted to push this, our collective and individual minds to is how we think about the water that we'll be managing 10 years out, 15 years out, and how do we make the water discourse as important as the net zero discourse, because they're inseparable from a climate context, right? So Thomas, if you could go to the next slide. And these two operations that are fundamental parts of the Alberta economy, one is obviously an aerial view of the Southern Alberta feedlot, and the other one is a fracking operation in northern Alberta in the big resource play we call the Duvernay. And they're both fundamental to the Alberta economy, but they're also huge consumers of fresh water and huge producers of wastewater. And my challenge to the group is to think about what are the new spaces of opportunity in pulling the ag sector and the oil and gas sector into better conversations around the climate, watershed health, biodiversity health, in a way that we start to share best practices around clean technologies, and whether that's membrane-driven thinking or whether that's business process thinking. But just, I want you to pause for a moment and think about some of these numbers. So that feedlot on the left is not even actually a full feedlot. That's a low ebb in the feeding season in terms of the way cattle are finished. But most cattle in Alberta go through a 200-day finishing process. So I'm going to talk about the water consumption of a single cow through that life cycle, 200 days. This is not what the cow consumes through its entire life. This is through the finishing process. So a typical cow being finished to be able to go to the processing market will drink, depending on temperature and what kind of nutrition they're being fed, will drink between 25 and 30 gallons of water a day. So if you think about that and you multiply that by a 200-day finishing cycle, and you think about it doesn't take too much imagination. We've all seen a cow pee, right? And that's a lot of wastewater. And around what's not in this image is all of the big lagoons and all the water management systems. To Kyle's great point, a lot of the water that are feeding these folks come out of the irrigation network in Southern Alberta, which is Southern Alberta is the most intensively irrigated area in the world, second most intensively irrigated area in the world outside of Israel in terms of its impact on these. So you can see that it's a big part of the economy. And so in other parts of the province, and if we turn our mind to, so that's a fracking job, and I assume we don't need the 101 on what fracking is. It's really fundamentally about putting huge amounts of chemicals and water and little beads of material called proppant down a well bore and pumping it a tremendous amount of pressures to fracture the source rock. And those little amounts of proppant go in there and they prop the cracks open and the hydrocarbons flow through those holes. The bottom line is it's drawing a lot of water, in many cases fresh water, fresh surface water from the watershed in which it's operating. It produces a lot of wastewater. All that flowback water is captured and it's treated in various ways. There's a whole argument around how much induced seismicity there is for the tremendous pressure we put the water under and whether it's actually moving the earth beneath our feet. But fundamentally, we've got these in this Alberta context, and we're not the only province where they frack and feed, but we do it at a scale that eclipses everybody else. So my challenge to the group is, How do we think about the role the academy plays, the role entrepreneurs play, the role innovators play in bringing these two sectors together for a more sort of productive set of conversations around sharing data, sharing processes, sharing the challenges they face. Both of these are big ESG determinants in both sectors. And so when we think about, and I see Jeff Stryker. Jeff, I had a long chat with Stan Blade the other day. Stan is the Dean of the University of Agriculture, University of Alberta Agricultural Program. We had this very conversation around the opportunities for these two sectors to think about new innovations in clean technology, new innovations in the way we use data, how we create employment down the road, coming back to how are we going to be feeding. As we sit here today, folks, guess what? We welcomed the 8th billionth person onto this earth. The 8th billionth person onto this earth, right? That person's going to want to breathe, drink, eat. How do we think about that down the road? And how do we think about how, all the great entrepreneurship and innovation processes that are at play, and all of a sudden the clean tech companies that are, and then how do we take this and export it globally as the way we do things between cross-sectoral sustainability work? So we got some phenomenal post-secondaries in Western Canada that are working on all this stuff. We got great innovation ecosystems. Foresight is a great platform for this. This is concerning other organizations like Results-Driven Agricultural Research here in Alberta, the Canadian Automatic CANE, the Intelligence and Data and Robotics Network. And surely there must be somebody out there willing to say, we need to get at this stuff collectively as an organization and think about all the value we can create, not only for Western Canada, but around the world. And then the last point I'll make in the context of this conversation, this is a phenomenally powerful way to start actually doing something about this whole idea about reconciliation based on Indigenous knowledge tools. These are both not only in physical watersheds, but they're both in the heart of Indigenous territories where there's a huge opportunity, as Shay said at the outset. Indigenous, they understand more about water and how water moves through the lungs of life than any other organization. What a phenomenal opportunity as well. So that's my challenge, is to how do you bring the industry companies, how do you bring the nutrients and the cattle feeders? And one of the important things about this conversation.
Oh, I think, Bill, you got muted.
And open it up for questions is, we tend to think about water and this thing is how much our plants drink, right? We think about irrigation and dry land farming in terms of precipitation, in terms of crop side of it. The livestock thing is a critically important part of the context as well. So that's it for me. Thank you, Shay.
Thanks, Bill. A question that Jay shared in the chat, and feel free to chime in if you prefer to speak out loud, Jay, but what if someone figures out how to decarbonize fracking water, bitumen tailings water, and agricultural wastewater? I have a question about your question. What do you mean by decarbonize in that context? If you're okay chiming in.
The key toxicity problem the key toxicity problem in all of these wastewaters is carbon wastes. Fracking, I mean, it's supposed to extract oil and gas, so inevitably the tailings from fracking are high water, but also, extraordinarily high minerals.
Right.
The same is true of tailings water. Naphthenic acids are, of course, a problem, but so is the fugitive bitumen that adheres to the minerals and prevents these particles, micron to nano, from ever settling. So by total decarbonization, that's what I mean. And I would call it, from just an idea point of view, cold coking. You're going to turn all the carbon into macroscopic, micron size, at least, carbon stuff, just amorphous carbon, or what we would call coke, depending on what in the petroleum industry, but isn't really petroleum coke. So that would be the concept. Whether you can do it or not, no one has, at least in any kind of vector that has economic promise or techno-economic value.
I'll take a first crack at that, and Dr. Stryker is spot on with that, because we haven't raised the issue of how we think about taking brackish water or contaminated water and returning it to its potable state, whether it can be consumed by humans, whether it can be consumed by plant life. And look at, in a lot of industrial applications, the water needs to be cleaned because it fouls machinery, it fouls, one of the other dimensions to Dr. Stryker's point is the whole lithium mining dynamic that's really exploding in Western Canada right now, where we're extracting, a rare earth metal out of what we call petromining or brine mining, and all of a sudden, what do we do with all of that water? And so, if the bright graduate chemists that he's training and supervising their PhDs right at the moment start to say, man, that's a whole lot of water that can be put to a whole bunch of other use. The real magic is in the chemistry and the membrane management, I think, Jeff. So
the real challenge is penetrating this invincible wall that says all the pertinent technology that's going to be discovered for water remediation has been discovered. So no one wants to take a chance on the right concept. Instead of addressing these problems, why aren't we trying to solve them? And these are big questions that really nobody can answer, but billions and billions of dollars of research money are thrown away on incremental improvements to what we can do today. Okay, we're not going to save the planet that way, and we're not going to reach social justice that way. And all of those things are important, but I just like to make the case for fundamental discovery directed toward these solutions as part of this equation. And of course, this is totally vested interest. So
if I could just add one more important point as we wait for more questions in the chat, and to build off what Dr. Stryker is saying so eloquently, is the reality, and this again uniquely in Alberta, we have 25 pilot projects proposed for evaluation in the carbon capture and sequestration space. Many of them will occur under the feet of and tractor wheels of farmers, and that is all going into saline aquifers in this first stage of these storage projects. And so there's this whole dynamic around water management, water safety associated with a net zero conversation tied to the climate. And so you can sort of see, there's, to Jeff's point, there's a lot to unravel here in terms of subsequent foresight conversations. But it's again thinking about the new spaces which in all these things occur, right? So.
Thanks, Bill. If there are no burning questions for Bill, I might go back to, so we'll just take maybe 5 more minutes in our larger group here for any questions that you have or things that you want addressed in our larger group. So going back to a question from Tom for Kyle, I believe. Is there any regulation impeding the collection and use of water on site? Was the question I saw in the chat.
Yeah, great question. So Manitoba operates on a first in time, first in right regulatory system. So the first person to apply for that water has preference for that water in a jurisdiction. Those rights are calculated on average flows 8 out of 10 years. So stripping away sort of the lowest flow year and the highest flow year and trying to come out with that average. But water withdrawals, both surface water and groundwater of less than 25,000 liters per day do not require a license typically. So those are the smaller amounts on site that you can collect, a farmer could collect in rainwater, excess surface water, and not require a license in order to do that. However, one of the issues is that many of the areas, specifically in applying for regulatory licenses in southwestern Manitoba, so we're talking about two hours west of Winnipeg, where all those sites of potato processing, plant protein processing, they're already coming up to their limit around allotments from the major water bodies and lakes, so rivers and reservoirs in that area, because of the amount of economic development that's happened. But there is, in this irrigation space, there is a sort of secondary opportunity around that conveyance specifically. So as part of our research and our work doing for the province of Manitoba, in their water management strategy, we commissioned a study from Stantec, global water engineering firm, to sort of find the hypothetical return on investment in irrigation in the province. And their calculations were that even while accounting for an inflow environmental needs, Manitoba has around 750,000 acre feet per year of excess surface water that could be redirected for human activity while still accounting for those downstream environmental needs. So that could theoretically provide about 1 to 1.5 million newly irrigated acres in the province. So there is that potential. It's just a lot of Manitoba's problems is its abundance of water is not located where it's needed. So that's that secondary opportunity around conveyance. And if that problem can be solved, like there's huge benefits to that. Right now, agriculture contributes about 6.5% of Manitoba's GDP, 5% of its total jobs, and it generates around 4 billion in exports every year. Based on Stantec's figures, if we just boosted Manitoba's current irrigation capacity by 25%, so that's roughly 30,000 acres, or only 3% of that available surface water they calculated, that would be between $38 to $70 million of added GDP per year and 17 to 34 million in added labor income each year. So there is that benefit if water can just be brought to the right place. So that's something that those are the projects we're currently like in discussions with Canadian Infrastructure Bank around that conveyance infrastructure. But there is that secondary opportunity around if irrigation on site on the small scale average farmer, if water can be brought to them, there is that appetite. Just for anecdotally, during that drought in the summer of 2020, many districts that lacked irrigation systems, farmers and producers were paying other water cooperatives in other areas to truck in water on a daily basis for their crops. So the demand for water conveyance from areas of abundance to areas of need is definitely there. Producers have demonstrated that they're willing to take on the cost of that. But there currently isn't really much sort of mass adoption technology around that can enable them to do that, or sort of that legacy infrastructure in place that they can build off of. So some water cooperatives have been trying to lobby the province to get and invest in more in that. And one of the things obviously is sort of the divide between a liberal government in Ottawa versus a conservative government provincially. So there is a lot of federal money on the table for these types of larger expansionary projects, but they just aren't happening at the speed that producers need them to happen right now, based on the year in sort of escalation in extreme weather. Fun fact, already before climate change really started accelerating last decade, Winnipeg was tied with a city in Siberia as the largest city of over 500,000 people with the biggest temperature swings. So already Manitoba has been an area of temperature swings, just because it's not nowhere near proximate to any large body of water. So farmers and producers have been used to swings in temperature for a while, but they're starting to realize that that's going to get much worse going forward.
More extreme. Okay. Thanks, Kyle. Thanks for that great question. For all of our speakers, before we shift to the breakout rooms, I'm wondering if we can make some connections across these problems or challenges that you've presented. So specifically, like, what do we see as some commonalities with the problems that have been articulated here, and also touching upon solutions. So just want to open that up. Kyle, Dana, Bill. Dana, do you want to jump back in? And you're muted again. No worries.
Truthfully, it is a difficult task to find commonalities between all three of these concepts. But I do think that what Bill and Kyle presented probably has a little bit more overlap. But something I've learned that I think is potentially of interest is that some of the best ideas I see coming into the post-farm gate food space are new applications of technologies and science that have been applied to other problems. So I do like that we have this diversity in the problem statements, as well as I'm sensing in our group. For instance, I'll give you an example that quite a few of our CFIN members have worked in cybersecurity and traceability and other types of supply chain authenticity types of spaces in agriculture. And they don't necessarily realize that with some minor modifications that they can move down the value chain. So yeah, I would just say that sometimes thinking about something that seems really crazy different will open up one's mind when they turn back to another problem with all of a sudden it's like, oh, look, there is a connection. It might be a dotted line, but it can lead to some really interesting and new, fresh ways of thinking.
Mm-hmm.
Yeah, I would second that. I think one of the pillars of sort of why Emily was founded was to promote workers or applicants of non-traditional agricultural backgrounds to get into agriculture as a means. I mean, I myself have no background in agronomy or hydrology. Maybe I shouldn't have said that, but I'm a political economist by background. So they saw my value as being able to lead the stakeholder engagement and be able to see the conflict of interest that inevitably come up around water, because you have so much vested interest between communities. And I think that like Dana was saying, that there is opportunity for interdisciplinary approaches to these problems. Should not be siloed off into as just agriculture, no pun intended there. But I think that especially, I know it's a shame that Bill had just left, but I know that one of the things that we came across as part of our work around finding solutions to water management issues is the speaking to the Manitoba beef producers and sort of beef industry in Manitoba. They really push that beef have an essential role in sort of land that's not necessarily deemed as prime agricultural land, and that sort of there is, especially as you're talking about expanding irrigation, you will come up to sort of diminishing returns and marginal returns, and you can't just blanket the land and irrigation infrastructure and expect the same sort of output from every square acre of every corner of the province. So I think just finding ways, whether it's approaching solutions through an interdisciplinary lens, or of course we all know that like there's a no one size fits all problem solution to a lot of these problems. So one area of Manitoba might have a water management issue or solution that doesn't work in another part because of soils, because of community involvements, because of industry. So I think trying to bring new perspectives in and not necessarily always trying to think that your road is leading towards a silver bullet, I think is an important way to solve some of these problems.
Mm-hmm. Yeah, hence the we talk about falling in love with the problem, or marry your problem, divorce your solution. So that is the kind of purpose of today's event. I appreciate that. So we've several people have dropped off at the top of the hour, so I'm actually going to suggest that we stay together in this larger group. But again, opening it up to questions, comments, just ideas, let's let it flow. I see a comment from Thomas in the chat, so I might go there first. So an interesting consideration could be Farmer's Hive, cloud-based monitoring solution, optimizing water management. So Thomas has shared a link in the chat. Do you want to say more about that, Thomas, or any questions or comments?
Yeah, sure. Hi, guys. Really interesting conversation. Yeah, so essentially what we've done, and we've developed a plug and play sensor device that records the moisture and temperature in the soil. A couple of barriers are, when these devices are out in the field, how they operate. With our IoT solution, they connect directly to the cloud. They optimize the moisture in the soil, therefore limiting the irrigation that's being pumped out. So water can be redirected elsewhere. or just kind of put together a little bit more efficiently, which ends up saving a lot of time and energy.
You have software that does this, that does the process management for you?
Yeah, so what we've developed is a cloud-based platform. And so once the sensor is in the soil, it connects, it sends up those metrics. And then the farmer or grower can set the actual parameters. So we don't take it over from the farmer.
No.
We allow the farmer to calibrate what the ideal soil moisture content is in order to prevent the plant from wilting. So what farmers do, and I'll just use a winery, for example, is that they're monitoring 200 or 300 acres of vineyards. Yeah. And so they're kind of just pumping out water to make sure that they've taken care of it. But the reality is that when you get into it, really the percentage of moisture in that soil can be optimized for them to, delay irrigating for a couple of more days, which is hugely important. Yeah. And so that's what we've noticed. And so for when the soil moisture drops down, the farmer sets that threshold, and that threshold then, once it's breached, it sends the farmer a notification, say, hey, your irrigation system in, block 23 Pinot Noir is, down below 20%. And the same with, potato fields, grains. Yeah.
Could the system direct more water, maybe at a marginally higher cost, to areas that, you're proposing essentially an infinitely distributed hydrology net, right? So if there were a source of water nearby or whatever, you could redistribute, take water allotments away from places with a normal amount of soil water and distribute it. That would be a next layer, but the management is, it's got to save huge amounts of water. So.
Yeah, absolutely. And I think it's really difficult for, any single person to optimize that. So, having this cloud-based technology really helps centralize the information. So that can be aggregated and then processed through different formulas and ideas that particularly work for that farm and in that microclimate. So, we're seeing it work as farms develop and they expand. It's unfortunate that they don't have the capacity to take on more labor or have access to it. So being able to monitor different areas of these, 1,000-acre farms, it's a really beneficial tool.
Thanks, Thomas, for sharing about your solution.
I'm just going to jump in there. And Thomas mentioned that one of the things that Emily has got involved with in the last couple of years is a site. It's about 45 minutes outside of Winnipeg called Rutherford Farms. It's a fully commercially operable 5,000-acre farm that we're using. We're just going to submit the application to join the Kane Smart Farm Network within the next week or two. But it's a 5,000 square foot, fully commercially operative farm that the owner of that farm is very, very passionate about using it as a test site for all these technologies and is looking for water solutions specifically. And that's probably something that I think he'd be very interested in hearing more about. I will type it in the chat here just in case anyone else is interested. But it's those are the types of things that I think we as Emily are wanting to use Rutherford Farms as a test site, specifically regionally here in sort of the Eastern Prairies for that type of work. So we'd be very interested in hearing more about that.
Yeah, that would be really great. And that sounds fantastic. And, we have our system across Canada and the United States. So as far east as Nova Scotia. And, it's one of our biggest challenges in development over this in the last number of years is being effective. So the actual technology itself has to be so intuitive to a layman, so to speak, to really kind of like get the best out of that product. And then a second portion of it is that it has to be super affordable, because obviously with constraints on budgets, especially when you're trying new technologies, a lot of people have been around the kind of clock on that a number of times. So, and we have so much to go on, because we have cloud-based technologies that are so scalable, and we produce units that are very tangible. They're on the ground. They're robust. And they offer really valuable information. And I think that if we can unlock, the correct amount of soil moisture a plant needs, that's really effective for a farmer to actually implement instantly. So we're talking in real time. We think that can be a really powerful tool.
Nice. I think Thomas had a question.
Yeah, I did. Just great comments there. The other Thomas on this call. It's a question for Kyle. We're talking about sort of really a little bit of the theme we've been digging into here is a one size doesn't fit all, and some really sort of great minds kind of working on this. Going back to kind of water conveyance, and I know you mentioned sort of you're looking at sort of Rutherford Farms as a potential test site. Are there any sort of pilot studies or any pilot projects that you're really excited and show some sort of great promise in terms of water conveyance or water distribution?
There's no projects that I know of that are that far along. The Pembina Valley Water Cooperative is a group that's in southern Manitoba that is sort of around that fast-growing agri-processing sector region. So they are looking at really advancing sort of a lot of these conveyance between their municipalities. I think we haven't seen a lot of that, both because frankly, there's just a lot of outdated information right now in Manitoba. I think the groundwater estimates that they're going off of for licensing and withdrawal are over 30 years old right now at this point. There's a lot of that type of thing that I think has just sort of that base level work and understanding your benchmarks that haven't been updated in a long time to be able to then do the hard work of negotiating between municipalities, of trying to get them on board, of sending their water away to a different district. I think that becomes then, it's both a technical problem, but also a political problem at that point. And I think that is going to be something to be both addressed in the future as part of this Manitoba Water Strategy Framework. I think one of the things in all our stakeholder engagement that we did throughout this past year has just been trying to understand and convey the sentiment from municipalities, from producers to the government, that it's really clear, or it's really important for them to have a clear idea of essentially where they sit in that hierarchy of needs when there are water shortages. So what happens when water starts to become low and another municipality needs it? What if it's becoming low in a municipality and you have to institute restrictions? Who does it go on to? Potable water first? Does it hit industry first? Does it hit producers first? And if it hits producers, does it hit the crop growers? Does it hit the livestock producers? Those are all a lot of questions that came up specifically in our drought in 2020 that I think people within their own communities, especially here in the province with a historical abundance of water, have never been used to confronting the idea of what to do in water shortage scenarios. So I think that work isn't as far along as it should be in other regions that have been more historically water stressed. As part of our work for the government, we did look into sort of best practices in other areas, whether it's Israel. We brought the architects of the California Water Plan to speak with Manitoba's government staff that were putting together this their water management strategy to try to learn the lessons of California that really sort of went all in on water conveyance in the 70s and 80s. And, to be frank, have not, that's come with just as many problems as benefits there. So I think that in some ways Manitoba has a blank canvas for this. We're a bit behind the curve, but we are able to learn from other jurisdictions in that way. And I think if there was one area that's going to take the lead on this outside of government, it would be that Pembina Valley Water Cooperative in that agricultural space in southern Manitoba that's really, really growing. It has some of the fastest growing communities in Canada, I think, because of how their agricultural or agri-food processing sector has grown. And then that brings along with it sort of spin-off economic development of other businesses to serve those industries and those communities just growing in and of themselves. So I think, yeah, if you're looking for a leader in Manitoba around that, it would be Pembina Valley Water Cooperative.
No, perfect. Thanks for that. It sounds like there's sort of multiple barriers to get over, sort of a double-edged sword, like you said, a blank canvas, and educating some of those key stakeholders, especially government, is really critical. So no, that's great. Thank you. Any other questions from the group?
I have a question for Dana. I'm wondering if we shift back a little bit to Dana's challenge. And then I'm thinking we wrap up a little bit early. Folks can actually go eat their lunches potentially. So Dana, turning back to the challenge that you proposed, and particularly the way that you honed in on like rethinking the way that we process food, and water not necessarily being a given. Can you give us a sense of the scale of the challenge, like given your work, like what are we talking about here?
Well, when you think about during the pandemic, the supply chain issues that we had at our ports, I think this is a really good example. So I had a great conversation with James Donaldson probably around last January or so. He is the CEO of the British Columbia Food and Beverage Association. And he socialized me to the fact that not only was the Port of Vancouver extremely busy and backed up with many containers that needed to be moved, but one thing that was really tragic is that many of the containers that contained fresh food coming to Canada from other countries, they were sitting and not being prioritized because there actually is no system at the Port of Vancouver to know what is in each container and which one should be moved first. So they basically, the way they work is if it's in the front, it gets moved. So if it contains razor blades or, dog toys, it doesn't matter. They move it first. So here we had all of this amazing produce and fresh food coming in frozen or refrigerated format, coming from other countries that literally was languishing on the dock and not getting to market in time. So if some of that food had water removed from it in a way that didn't harm its quality, obviously the texture of fresh food is always going to be desirable, and we're going to want to have fresh lettuce and any other fruit or vegetable that you can imagine. But just think about how much more of a product that was just going to go into our food processing stream or into some other type of a use, like maybe, well, I guess it's the same, like say going into making, I don't know, some kind of a mix, like a cake mix or a pudding or who knows what. If those goods had had the water removed from them in a sustainable way that maintained the nutrition, we would have had way more stuff in that large container, and it wouldn't have been as sensitive time-wise. And when they got to moving that container and getting it onto a train to come here to Ontario or to Quebec, it would have still been usable. So it is a really big impact, not just for the companies who ended up having to put in insurance claims against that kind of loss, but in nutrients and in, you know, in an opportunity. When you think about what's happening at Canada's food banks right now, and the number of people who are living in long-term care homes where the budgets for feeding them for a full day are often under $10 for groceries, we need to find savings wherever we can. And if some of, you know, these types of ideas can help, then fantastic.
Thanks, Dina. I feel slightly overwhelmed by the whenever I learn more about challenges in different ways. It's like the multi-layered ways in which food sovereignty, food security, transport, etc. Any other questions or comments from the group before we close a little early? Okay. So you have contact info for our speakers, Dana, Kyle, and Bill, who had to drop off. Thanks so much for your time. We really appreciate it. Also want to thank Nisha, Thomas, Astrid, who's also hopped off from my team, for supporting today's event. And yes, we can share recordings of past sessions if you like. Just feel free to reach out. I think that was Jay that was asking about that. And then we have more events coming up in the future. So our next event will be focused on carbon, all things carbon management, CCUS, on January 25th. So feel free, you can see all of our events at foresightcac.com/events. And also want to thank IRAP for their ongoing support.